Okay, guys. So today, this is session seven, oligopoly models. Um, this is a new market structure that we learned today, different from what we had before for monopoly and perfect competition. So in perfect competition, the idea was very simple. Many different players. There was each person was a price taker, no influence on the price. We just accepted whatever the market gave us. That was one extreme of the market. The other extreme was monopoly, where from many players it came down to one player, the guy who controls the market, and uh, he was the price setter. Now we have oligopoly. Oligopoly is in the middle of perfect competition and monopoly. It has few firms, so not a whole lot like perfect competition, and obviously not one. Few means like two, four, six, but a few firms as opposed to 50 firms. So we'll learn different models of oligopoly under the structure. And then we have another variant of oligopoly where again there are few firms, but there's one dominant firm, and then the rest are follower firms. The the key point in oligopoly is interdependency. That in an oligopoly market, the players cannot decide just by themselves. Like in monopoly, the monopolist doesn't have to care about anybody. He makes all the decisions himself. In perfect competition, it doesn't really matter because you are just a decision taker. You don't a decision maker. But in a oligopoly, you have when you make a decision at the firm, you not only have to think what is best for you, but you also have to anticipate what the other party will do. And that idea of interdependency is really what's the differentiating factor. So when you think oligopoly, think interdependence, and we'll learn how to calculate that interdependence. And that interdependence is calculated by something known as reaction curve. So we'll study oligopoly market basic structure. Then we'll go through a number of examples of different variants of the oligopoly structure. Kuno, Stackelberg, Bertrand, the three major ones. Then we'll also study collusion and cartel. And then finally, the structure of dominant follower firm. In the exams that I posted that you guys have access to, there are at least two questions on this idea. There would be a question directly on this idea, and then there might be a question coupled with game theory on the same idea. So game theory and oligopoly models are highly, they're connected. They're the same basically. Okay, so let's start with a simple example that in oligopoly markets, the firms have to worry about competitive interdependence. So a motivating example, take the chips market where you have three firms, Samsung, NEC, and NVIDIA. They're making this DRAM chip. Um, and the decision that Samsung will make will not just depend on what Samsung wants to do, it will also depend on what it anticipates NEC and NVIDIA would do. So, simple example, if you are running Samsung's chip division, you cannot just wake up one day and say, hey, I want to double the production because you feel like it. If you build a massive new factory, and flood the pipeline, but NEC and NVIDIA do the exact same thing, the global supply explodes. Okay, and chip prices crash. So even if you're the Samsung VP, you got to anticipate what NVIDIA and NEC are going to do to your action. And that's what that interdependence is really the hallmark of oligopoly models. So we'll try to quantify that in a second, like how do we quantify the interdependence and what do we need to do? This is a quick summary map that how we think about all the oligopoly models. Obviously, there is at the highest level, you can break it down into two scales, a non-cooperative oligopoly model and a cooperative oligopoly model. In the non-cooperative sense, you have these variants, Cournot, Stackelberg, Bertrand, and the dominant follower. And in the cooperative sense, you have collusion and cartel. The way to do this is shown here, but we'll go through that in a second. But this is a good cheat sheet to come back to. So let's start with the very first one, which is non-cooperative, but the Cournot model. Okay, so Cournot model, what are the characteristics of Cournot model? First is the obviously the goods are homogeneous. So, the three or four companies that are there, they make the same good. Uh, the second, probably more important thing is that the decisions the firms make are simultaneous. So take the two examples, a two firm example called a duopoly. Both the firms are making the decision simultaneously. The simultaneous decision making is a key for Kurno. And second, decision making on what? They are deciding on how much to produce. You could have a simultaneous decision making on price. You can decide simultaneously what the price should be. That's called a Bertrand model. But if you're deciding simultaneously on how much to produce, Q, that's the Cournot model. So I will write down the first thing here is Cournot model has two characteristics. One is, what happened to the pen? Just 1 second. Hmm. That's interesting that my tablet is not working. Why is it not working? That's the problem. Well, if I can't write, just 1 second, guys. Let me check. Why is it? Okay, well, we'll have to try it without the pen then. That's not good. Okay, so let's go back here. Let's yes, so let's go back here. Sorry. So simultaneous decision making and how much to produce. So they're deciding on how much quantity and making the decision simultaneously. So let's now figure out how do we calculate this interdependency. So let's say there are two firms, A and B,
Sorry,
or maybe
Pras,
yeah,
you could try the annotate tool on Zoom if that works. If you go to your screen
yeah.
share.
My this pen, yes, I see the pen, but it's not writing. I don't know why it's not writing. Uh, just 1 second. Let's see. Um, I'm running out of ideas here. Why is this? Maybe hold on. What is? Yeah, I'm trying to. I could write it with my uh, with this thing with my mouse, but the writing will not be as good as if the pen doesn't work. Okay, we'll try. I mean, sorry about this. I mean, it's like maybe somehow some setting got messed up. Yeah. Okay. Well, I'll try to do it with the mouse. It won't be perfect, but I think we can still manage it. But let's understand the concept. Let's say there are two firms. Um, let's say there are two firms, uh, one and two. So firm one, if you think about firm one, how does a firm one decide how much quantity to produce? Well, if you look at the monopoly idea, the idea was, well, if you have a demand curve like this, D1, comma 0 means that firm 1 expects the entire demand to be satisfied by firm 1 itself. It expects firm 2 to make zero quantity. So if the second firm makes zero quantity, this problem becomes a problem of only one firm, right? So the demand is satisfied by firm 1 only. If you have one firm, how do we decide how much to produce? Well, you calculate MR. That's the monopoly problem. You find where MR equal to MC1, and that gives you the quantity. So if the firm 1 assumes that the second firm will produce nothing, the quantity that firm 1 will produce is 50 units. Everybody understand this point? How the 50 comes? 50 comes because firm 1 is assuming firm 2 is producing nothing. Now that may not be the case. Firm 2 may actually produce some quantity. Let's say the firm 2 produces 50 units. If firm 2 produces 50 units, then the demand that the firm 1 satisfies is the total demand, this one, minus 50 units that firm 2 produces. So that's this dotted line, D150. And then if that's the dotted line that firm 1 is satisfying, or the demand that's facing, then again the way the firm 1 will set its price and quantity is by calculating MR and then finding where MR equal to MC. So that's 25. So what you see here is that firm 1 will produce either 50 units if it thinks firm 2 produces 0, or firm 1 will produce 25 units if it thinks firm 2 will produce 50. So depending on what it anticipates firm 2 to do, it will produce a different quantity accordingly. So this idea of looking at what the others are anticipated to produce uh, is the interdependency. So how do we know actually, and it keeps going on, that it says, well, if the firm 1 assumes that the second firm will produce 75 units, then it will produce 12.5 and so on. So this idea of what firm 1 is anticipating is the reaction curve for firm 1. Okay, so how does the reaction curve work? So the reaction curve, if you see this plot here, the reaction curve for firm 1, what I'm plotting is Q1 is the amount that firm 1 produces, and Q2 is the amount what firm 2 produces. If I follow this line, sorry, here, this one, this is firm 1's reaction curve. Any point on this curve is a Q1, Q2 combination. So if it assumes, if you look at this number, if it assumes that Q2 is 0, that is firm 2 produces nothing, then firm 1 will produce 50 units. If it assumes Q2 is 25, that means firm 2 is producing 25, firm 1 will produce this amount. If it thinks firm 2 will produce 50, firm 1 will produce 25 and so on. So that's the reaction curve. The reaction curve for firm 1, really the equation for this curve is nothing but MR1 equal to MC1. So the marginal revenue of firm 1 equated to its marginal cost gives you the reaction curve of firm 1. Similarly, firm 2 is developing their own reaction curve. A reaction curve for firm 2 means that it anticipates how much it should produce by assuming what it thinks firm 1 will produce. So they both the firms are now trying to anticipate each other's production. And this equation for firm 2's reaction curve is given by MR2 equal to MC2. So in the end, an oligopoly model is really the intersection of the two reaction curve of firm 1 with the reaction curve of firm 2. So when you solve these two equations simultaneously, that is R1 and R2, R1 is MR1 equal to MC1 and R2 is MR2 equal to MC2, you get Q1 and Q2, and that's really the Cournot model. The Cournot model is frankly the intersection of the reaction curves of the two firms. Okay. Um, that's the general idea. So a Cournot equilibrium is an equilibrium in which each firm correctly assumes how much its competitor will produce and sets its production level accordingly. So let's take an example and see how we get to it. So here is the recipe for solving it. And in each of the cases, I give you the recipe on the left. But let's say you had a situation where the market demand for a certain product is P equals 30 minus Q. Think of this as maybe the market demand for chips is 30 minus Q. And there are two firms, Samsung and NEC. Samsung's marginal cost is 10, NEC's marginal cost is also 10. So the question is, well, if they are both competing, making decisions simultaneously and deciding on how much quantity to produce, how much will Samsung produce and how much will NEC produce? That's really the thing. So in the Cournot case, we know a recipe. A recipe is, well, get the reaction curves of the two firms. In this case, firm 1's reaction curve is MR1 equal to MC1. Okay, in many, uh, so we got to calculate this thing. MC1 is given to you as 10. The trick here is, how do we calculate MR1? So pay attention. MR1 is price times Q1. Price is the market price in the oligopoly situation times Q1, how much firm 1 produces. That's the revenue of the firm 1. So if you write down here, price is from the demand equation 30 minus Q times Q1. Obviously, Q is summation of Q1 plus Q2 because Q will be supported by both the firms. You can open it up as 30 minus Q1 minus Q2 times Q1. Open it up further, 30 Q1 minus Q1 square minus Q1 Q2. Okay, so that's my revenue of firm 1. The marginal revenue of firm 1 is the first derivative of this total revenue with respect to Q1. Very important. You take the derivative with respect to Q1, not Q2, to get the marginal revenue of firm 1. So when you differentiate this thing with respect to Q1, treat Q2 as a constant in the Cournot model because both of them are making decisions simultaneously. So when you differentiate this thing with respect to Q1, 30 Q1 becomes 30, Q1 square becomes 2Q1, and Q1 Q2, treating Q2 as constant becomes just Q2 because Q1 goes away. So marginal revenue is 30 minus 2Q1 minus Q2. Obviously, equate that to MC1, which is 10. You get this equation between Q1 and Q2. So that is the reaction curve of firm 1, which means that firm 1, depending on what firm 2 will produce, Q2 will produce Q1 accordingly. If Q2 is 0, firm 1 produces 10 units. If Q2 is 2, firm 1 produces 9 units, and so on. Let me pause here. The trick here is all about how do you calculate MR1. Do people see how we did MR1? We first got the revenue, then differentiated the revenue with respect to Q1, holding Q2 constant.
Pras, this red Q,
Yeah.
you replaced it with Q1 minus Q2.
No, Q1 plus Q2.
Oh,
Q1 plus Q2, right? Because it's so uh, this is where my
oh
pen
yeah,
is.
yeah, got it. Yes, Q1
Yeah,
plus. Got it.
yeah.
Yes.
Okay.
Okay, got it.
Hey,
Okay.
Pras, can you hear me?
Yes, yes.
So, so I understand all of this, right? But I was wondering for problems like these, is you were mentioning that in the last slide that each firm is going to produce based upon what they believe the other firm would produce, right?
Yes.
How, I don't know if it's relevant, but how do they determine or how do they estimate rather how much each firm or the other firm would produce?
Oh, they don't know. So all they are estimating is this equation. They're all they're estimating is this equation that hey, the relationship will be between Q1 depending on what Q2 comes out to be, I will produce based on this relationship. This is what firm 1 is designing. Firm 2 is doing the exact same analysis that depending on what firm 1 produces, I will produce Q2 based on this relationship. And the equilibrium will be where these two equations intersect each other. So firm 1 is anticipating based on this equation and firm 2 is anticipating based on these equations. Both of them are doing the same thing at the same time. And in the end, when the two things converge, that's when each firm has maximized their individual profits.
Okay, copy that. Thank you.
Yeah. So the thing is, it's not like firm 1 can uh, wait and observe and then decide. But if you do that, then firm 2 has a first mover advantage, right? And that's the Stackelberg model. Here, the way it's working is think about this way that look, firm 1 is anticipating uh, the Q1 production based on this relationship with Q2. Because what they know is here's my market demand. They know this thing. They don't know what firm 2's cost structure. They know their own cost structure. So they can compute how they should react based on firm 2's action. And firm 2 is doing the same analysis. And then the market will equilibrate where the two reaction curves intersect, which was this point, as you saw here.
Okay, gotcha.
Which was this point, yeah.
So yeah, we're calculating the quantity at that point.
For both this point is the intersection and the equilibrium is you get Q1 for firm 1 and Q2 for firm 2. Yeah.
Got it. Okay.
So let's
So
play this out. Yeah, go ahead.
sorry. So for these type of problems, you would need the market demand and the marginal cost for each firm in order to solve for the quantities.
Exactly. You will need the market demand, and that has to be given, obviously, and then the marginal cost or the cost function for each of the firms. Yeah.
Okay, thank you.
Yeah. So here, if I solve these equations, both all of you should know how to solve two equations, two variables. You get Q1 and Q2 as Q1 is 6.67, Q2 is 6.67, and then the price is, 30 minus Q. Q is Q1 plus Q2, 13.33, so that's 16.67. Now here, obviously, the amount is the same for both the firms because the marginal costs were the same, but that may not be the case depending on if the marginal costs are different. Okay. So that's that. The one other thing I would say is if you were to solve the same problem using a different market structure like perfect competition or monopoly, typically you will find that the price under perfect competition would be the highest. Sorry, the price under perfect competition will be the lowest. A price under oligopoly will be in between that, and then price under monopoly, if there was only one firm here, will be the highest. So that's sort of your expectation in terms of price, because sometimes he says, well, what if the market was monopoly, or what if the market was perfect competition? A quick way to check the answers is that in an oligopoly situation, your price will be between monopoly and perfect competition. Perfect competition, you prices are the lowest, best for the consumer. Monopoly prices are the highest, worst for the consumer, and oligopoly is in between. The quantities follow exactly the opposite trend. In perfect competition, the quantity produced is the highest. In monopoly, the quantity produced is the lowest, and oligopoly is in between. Okay. So this is Cournot structure, and we'll do so many problems in the next hour that hopefully this will start to see a pattern here. Okay. Okay, so let's try the next one. So now we did Cournot. Now we do Stackelberg, which is the second model. So Stackelberg has a different structure. Again, an oligopoly structure, but the decision making is sequential, not simultaneous, which means the two firms, one of them has a first mover advantage. So they go first, they decide how much they will produce, and the second firm follows. So that sequential nature of decision making changes the model. Okay, so that's one thing. Second, what are they competing on? They are still competing on quantity. So they're deciding how much to produce, not on price. So Cournot and Stackelberg both have the same structure. The firms are competing on quantity, not price. Difference being Cournot, the firms make decisions simultaneously. In Stackelberg, they make decisions sequentially. Okay. So now let's look at the same problem here. Same problem as before, but with the additional caveat that firm 1 has a first mover advantage. Firm 1 has a first mover advantage. That means firm 1 goes first. Okay, so how do we do this thing? Our principle is the same. Get the reaction curves, the two firms, and then solve the two reaction curves. But there's a sequence on how we get the reaction curve. In Stackelberg model, always start with the follower firm. That means firm 2, which is following. Start with firm 2's reaction curve. The reaction curve for firm 2 is MR2 equal to MC2, which is the same as how you did a Stackelberg. To get MR2, you get the total revenue for firm 2, which is P times Q2. P is 30 minus Q times Q2. You open it up, you get the same sequence that you got for Cournot. No change so far. When you take the first derivative with respect to Q2, treat Q1 as constant. Treat Q1 as constant. So you get 30 minus Q1 minus 2Q2. Equate that to the MC2. So you get the reaction curve for firm 2. So far, the reaction curve for the follower firm in Stackelberg is exactly the same process as the reaction curve for the second firm in Cournot. No change so far. We treated Q1 as constant when we did the differentiation. Now comes the change. So now I go to firm 1, which is the leader firm here, and calculate its reaction curve. Same idea, MR1 equal to MC1. So this is similar. You get TR1, which is PQ1. So this is similar. But now the trick, before you differentiate, you replace Q2. You replace Q2. So 30 minus Q1 minus Q2. You replace Q2 with firm 2's reaction curve. With firm 2's reaction curve. And the reason you do that is because firm 1 goes first. It knows what the reaction curve for firm 2 would be. It knows how much firm 2 will produce because firm 1 is setting up Q1. So firm 2 will look at Q1 and produce Q2 according to firm 2's reaction curve. So in firm 1, when they are calculating their revenue, they can write down Q2 as a function of Q1 from the reaction curve of the second firm. So now when you expand it up, you have the total revenue of firm 1 in terms of Q1 only, because Q2 depends on Q1. Now you can take the differentiation, so it's just 20 minus Q1, equate that to MC1, so you get Q1 equal to 10. From Q1 equal to 10, go back to the reaction curve of firm 2, you get Q2 as 5. So the key difference here for Stackelberg is there is no change for the follower firm's reaction curve. Firm 2's reaction curve is the same as what we would have gotten in Cournot. But firm 1's reaction curve, you eliminate the second quantity Q2 from the reaction curve of firm 2, and then you differentiate. And that's how you get Q1, Q2. So that's the difference between Stackelberg and Cournot, and how you do this thing. Let me pause here and see if there are any questions. Do you see the subtlety here between how we did Cournot versus how we did Stackelberg?
Yeah. Could this sequentially be like mapped onto multiple? Like, could there be one reacting, like one's reaction going on to the second to the third, if we were looking at multiple forms?
Yeah, it can be. So again,
Okay.
in those cases, I mean, let's say there are 3 firms and there's one dominant firm and the other's a follower firm. We'll do it a little
Right.
bit differently.
Okay. Got it.
But you will not get a case where it's like 1, 2, 3, and all of them are equally important. So no, not that way.
And
But always, the point I was trying to make here is the firm 1, it will know what the firm, and if it's a leader firm, it will know how firm 2 will react, and therefore the second quantity Q2 is not really independent. It depends on Q1, and that's what you have to comprehend in computing MR1.
got it.
Okay.
And then, sorry, just a quick question
Yeah.
also. In this, then there's no, because there's a market price, there's no scenario or possibility of P ever differing. It'll have to be the same across all firms.
There's no possibility of what? P?
The P, there's never going to be a scenario of a P1 or a P2,
Oh, there's
unlike a
no P1 or
volatile.
P2.
Yeah.
It's common price because you have Q1 and Q2, but the prices, there's only one price because they're
Okay.
competing on quantity, not on price.
Okay. Got it.
Yeah.
Sorry, I have a quick question too. So in the exams, are there particular keywords where we can identify which one is the reaction firm and then which one is the first mover?
Yeah. So they will tell you that, and as you will see in a few minutes, Angela, they will say that firm 1 wants to have a first mover advantage. So you'll know which one is going first.
Okay, great. So once we see someone is the first mover, and then we always start working on the reaction firm first.
Yeah. So no, not the reaction part. When you
Uh,
would know which firm is going first, that you will know. And
okay.
all I was saying was, in the end, we're always solving for reaction curves.
Mm-hmm.
What we will do here is we will start with the second firm's reaction curve.
Second firm. Okay.
Right. That's what I
Got
meant.
it.
Yeah.
Okay, thank you.
Yep. Good questions. So again, first time when you see it, it's a little bit tricky, but you'll get the hang of it as we go through more exam problems. Okay, so the Stackelberg leader provides an advantage. Why does the first firm have an advantage in Stackelberg? Okay, so where is the advantage? Advantage is here, as you see, that same sort of structure as before. same sort of same conditions that we did for Cournot, right? But here the quantity produced, if you notice here, Q1 is 10, Q1 is 10 and Q2 is 5. Whereas in Cournot, they were both equal, like 6.67 and 6.67. So clearly firm 1 is producing more in the Stackelberg case. So that's the advantage of going first. So you see that getting reflected in the quantity produced. So the question then was, well, why does today this, God, this is like, I don't know why I can't get this mouse to work properly. Okay, so the Stackelberg model provides an advantage because the second firm must accept the leader's large output as given and produce a smaller output. So because they're a follower, they're just following whatever the leader wants to do. The leader takes a bigger share for themselves. And uh, so the follower firm basically accepts whatever the leader has given them. If the second firm decided to produce a larger quantity, let's say it neglected the reaction curve, this would reduce the price and profit for both the firms because the price will then fall down because you're producing more quantity than is needed, which will hurt both the firms. So really the second firm in its own interest has to follow the first firm's lead. So that's really why the first firm has the advantage to produce more. Okay, the third one is Bertrand model. Bertrand model is similar to Cournot in the sense that both the firms are making simultaneous decision making. That means both the firms are deciding at the same time. But now they are not deciding on price or on quantity, they're competing on price. So Bertrand is the classic undercutting each other. The two firms decide, hey, if you're going to put a price of P1, I'm going to do a price of P2 where P2 is less than P1. And so they keep undercutting each other, but they're making the decision simultaneously. Our approach doesn't change. Our approach is, hey, okay, well, even if you have a Bertrand model, our procedure is get the reaction curve of firm 1, get the reaction curve of firm 2, and solve the two reaction curves to find the equilibrium. In case of Bertrand, the reaction curve is price equal to MC for firm 1 and price equal to MC for firm 2. This is a special case of reaction firms because what this is saying is that the two prices are going to be the same in the end. And the reason for that is if one price is higher than the other price, the firm with the lower price takes the entire market. So in the end, the two prices have to be the same for the two firms to coexist in a Bertrand model. That's why P1 equals P2. The firms cannot set different prices because the firm that will set the lower price will always win the whole market share. So in the end, they have to be equal. That's the equilibrium point. So P equal to MC1, P equal to MC2, these are the two reaction curves. You solve them together to get the quantity. And in this particular case, for these examples, it's 10 and 10, and then the price is 10. So notice the numbers here are different from what Cournot was. Cournot, under the same conditions, was 6.67 and 6.67, and the price was 15. In Bertrand, same quantities but higher quantities and the price is lower. So what does that tell you? That tells you that if the firms were competing in a Bertrand model, they will always be worse off. So that leads to a price war than they are competing on a Cournot model. So firms typically prefer to compete on quantity, never on price. Okay. The one other comment here is, hey, what about if we knew that one of the firms had a higher marginal cost than the other ones? Let's say firm 1 was 10 and firm 2 was 20. What happens then? Here the answer is very obvious that any firm whose marginal cost is higher will lose out completely because the firm with lower marginal cost has the ability to go lower in price. In this case, firm 1 can lower the price up to $10. That will be its profit maximizing quantity P equal to MC1. Clearly, if firm 2's MC2 is higher than 10, it can never come down as low as 10. So firm 2 will get nothing. So the entire market will go to firm 1 2 gets nothing. So that's sort of an intuitive answer that if you had definitely a situation where one firm has a lower marginal cost in the other firm, the firm with the lower marginal cost will take the entire market. Okay, so let's summarize what we have so far. What we have so far is Cournot, Bertrand, and Stackelberg, which is on the left-hand side of this thing. In Cournot model, simultaneous decision-making, firms are competing on quantity. You solve for the two reaction curves, MR1 equal to MC1, MR2 equal to MC2, and solve for Q1 and Q2. When you're computing MR1 and MR2, you treat the other quantity. So in case of MR1, treat Q2 as constant. In case of MR2, treat Q1 and constant, and get the marginal revenues that way. In case of Stackelberg, the criteria is the firms are sequential. They are not making decisions simultaneously. That means one firm has a first mover advantage, and the firms are competing on quantity. Here the process is start with the second firm, the follower firm, compute its reaction curve. That reaction curve is computed exactly the same way as you compute in a Cournot model. Okay, but then once you get the reaction curve of firm 2, use that to get the marginal revenue for firm 1. Use that second reaction curve directly into the marginal revenue for firm 1, and that's how you get the reaction curve for firm 1 and the quantity for firm 1. Bertrand is back to Cournot, simultaneous decision making, but now instead of competing on quantity, you're competing on price. And the governing equation says price equal to MC1 is the reaction curve for firm 1, price equal to MC2 for the reaction curve for firm 2. Okay, so we have covered this part. We haven't talked about dominant follower yet, but we'll come to that in a second. But we have covered Cournot, Stackelberg, and Bertrand. That's the non-cooperative oligopoly. Now we go to the other side, which is the cooperative oligopoly, collusion and cartel. Collusion and cartel model is something that you might recollect. This is a multi-plant monopolist. A multi-plant monopolist was that, hey, I have a demand that I have to satisfy, but I have multiple plants. How do I allocate the quantity across different plants to satisfy the demand? And that was MRT equals MC1 equal to MC2. Recall that from a midterm? A cartel is the same. You have a demand. Think of multiple companies working together as a cartel, and each company can be thought of as a manufacturing site for a multi-plant monopolist. So the cartel equation is the same. Cartel collusion is the same as what a multi-plant monopolist equation is. MRT equals MC1 equal to MC2. Okay, so let's take that example here. Basic steps to solve cartel. A cartel or a collusion is similar to a monopolist having two plants. So that's my governing equation. MRT equal to MC1 and MC2. As I told even before the midterm that in this particular case, always start with MC1 equal to MC2 because that gives you a relationship between Q1 and Q2. And then using that relationship, go back to either MRT equal to MC1 or MRT equal to MC2 and get the values. So let's take an example. Two firms face the following demand curve. The demand curve is this. The two firms' cost functions are given. What will be the price and output if the two firms decide to collude? Okay. So what do you think? Well, what's our process? Our process is, well, the multi-plant monopolist is MRT equal to MC1 equal to MC2. So let me start with MC1 and MC2 and equate them. So MC1 is 8, MC2 is Q2. I equate the two things together, I get Q2 equals 8 directly from the first shot. Okay. Now I go and say, well, I also have to use MRT equal to MC1. The trick is in how you compute MRT. This should be MRT, by the way, not MR1. MRT equal to MC2. Well, to get MRT, you have to write first TRT, total revenue. Total revenue is price times quantity, where quantity is the total quantity, which is Q1 plus Q2. You keep it in terms of Q2, QT, the total. Take the derivative with respect to QT, that's 200 minus 2Q. And now open it up in terms of Q1, Q2. So MRT is 200 minus 2 times Q1 plus Q2. That has to be equal to MC2 or MC1, doesn't matter. You can pick either one. If you pick it equal to MC2, uh, that's actually MC1. Put it equal to MC1, then that's 8. You know Q2 is 8. So you can solve for Q1. Q1 is 88. So that's really the the cartel or collusion equation where all you're solving is a multi-plant monopolist. Let me pause here. Does it make sense so far?
The math makes sense, Pras. But in general, in reality, which model reflects reality the best?
Well, it depends on how the firms are competing, right? I mean, they can decide to cooperate, and in which case this is how the quantities will be decided across the two firms because they have different cost functions. They can decide to compete based on like a Cournot competition, in which case the allocation of quantities will be different. So it depends on how the firms choose to compete, whether they want to compete or whether they want to cooperate. And then what this is showing is that depending on how they decide to work together, you have different outcomes, and that's really leads to the whole idea of game theory and so on. That you can have different outcomes depending on how each of you react to the situation.
So
That's the
would you
whole idea
say
of
that,
oligopoly.
yeah, I understand. So would you say that, Apple makes iPhone, Samsung makes a smartphone, and Google does too, and all of their prices are pretty high and comparable for similar models? So you think that they would be competing on quantity? Is that like an
So
example
usually
of
you yeah
oligopoly?
so yeah so usually if you think about these firms, they always they either compete on quantity or quality, right? I mean, nobody uh, tries to say, hey, buy my Apple iPhone because my prices are a little cheaper. They always, if you think about Apple or Google, they always highlight their quality differential between each other.
Mm-hmm.
Uh, because they are saying that, well, the product is not the same. I mean, these models all assume the products is homogeneous. That means that there is no difference in the quality between Apple and Samsung and so on. If that was the case, in that ideal case, you have the firms have two choices. Either you compete on how much you produce, or you compete on what price point you offer this thing. Clearly, if you compete on price point, the net profit for both of them will go down. So who does that way? So think about the guys who sell gasoline, the petrol. You know,
Mm-hmm.
in a pump, right, whether Exxon is selling gas or Shell is selling gas. I mean, we all try to differentiate the, hey, my gas is better than your gas. But in reality, for commodity like gas, it's more or less the same. So in the customer's mind, there's no quality differential. So it's homogeneous goods, unlike Apple and Samsung phones.
Okay.
So in that case, what can Exxon and Shell do? Well, they try to compete on price. And the way they attract you to the station is whoever has like 5 cents cheaper price. And that's the
Mm-hmm.
Bertrand model. But in the end, that's why it's not a great business because you don't make much money that way.
Mm-hmm.
But on the other hand, if they are really smart, they should compete on quantity. But that's not how they do it because the options are so many that controlling the quantity is not enough. Uh, so that it all depends on how the firms decide how they want to compete. Best way to compete is to show a quality differential. That way, you're not talking price. You can still keep some margin for yourself. Okay.
Okay, understood. Thank you.
Yeah. So let's go to the bunch of problems we have. So we'll go through many exam problems. Uh,
Russ, I have a quick question before
yeah,
you dive in the problems. So,
yeah.
when you're getting to a Burton model, you're essentially devolving into a perfect competition.
Yeah. You are devolving into perfect competition. That's right.
Okay, got it. But
Yeah.
there'll be ways to differentiate that when they ask, or it's just there's no scenario of them that overlapping at all.
Say that again.
So, will it ever like come up like in an exam? Let's say we're basically working with a Burton model because it's a we're being asked scenarios in an oligopoly. It'll never really conflate that or versus a perfect competition scenario.
Yeah, the perfect competition would be like, you know, what would be a perfect competition? The perfect competition would be that price is already set by an external factor beyond individual firms. In this case,
Okay.
the price will be set by the
Hmm.
guy whoever has the lowest marginal cost.
I see. Okay, yeah. Okay, that's the distinction. Got it.
Yeah. Okay, so this pen, something is broken, so I guess the pen will not work. All right, let's a lot of you ask like, hey, how do I know which model to operate with? So I think the next few examples will teach you that. So let's go through one by one. And I put some examples from like way back when. This was my class, my exam, 2007. But then obviously there's more recent ones. All right, so two companies uh, are licensed by National Park Service to operate tours to Alcatraz Island. Both companies face the same market demand curve. So the market demand curve is given. The primary way they compete is by adjusting the quantity of tours they offer per day. So you know that they are offering, they're manipulating or they're competing on the quantity. Fractional tours are possible, all quantities are below. So they're making decisions simultaneously, and so it doesn't say it's simultaneous decision making, but it's obvious that since they don't mention that one firm has a first mover advantage, the default case is simultaneous decision making. But they say very explicitly that they are competing on quantity. Okay, what else is given? They're saying that the two firms, their cost function is given to firm one, the 3P firm, Paul's Prison Peoples, they have this cost function. The 3D firm, they have this cost function. That's given to you. Okay. What else is given? Well, in addition to that, uh, you are also given the market demand, which is 140 minus 2Q. And then the question is, well, what will be the quantity supplied by each firm and what's the market price? Okay. So this is a classic Cournot equation situation. And in Cournot, you know the model is, well, I need the reaction curve for firm one. I need the reaction curve for firm two. And then I solve the two reaction curves simultaneously. So what is the reaction curve for firm one? The reaction curve for firm one, in this case, the firm P, is MRP equals MCP, right? So that's the reaction curve for firm one. So let's first get MRs for the two firms. MR for the first firm, call P equals 1. MR for the first firm is TR1. TR1 is price times quantity, Q1. Price is the demand equation, 140 minus 2 QP plus QD times QP, because we're talking about the firm P. Expand it up, you get this equation. When you are calculating the marginal revenue in Cournot, treat the other quantity as constant. In this case, I'm going to calculate the marginal revenue for firm P. That means I'm going to differentiate TRP with respect to DQP. So with respect to DQP. So if you have to write it down, MRP equals D by TRP. Is terrible handwriting. TRP divided by DQP. Okay, that's what we're trying to do. So that's what we do here. If we differentiate this with respect to QP, you get 140 minus 2QP square is minus 4QP. And you differentiate here, treat QD as constant, so minus 2QD. So this is how we get MRP. Do the same thing for the second firm get MRD. That's what he, and when you are taking the differentiation here with respect to QD, treat QP as constant. So you got MRP, you got MRD, set them equal to the corresponding marginal cost. So this is the reaction curve for firm 1. MRP equal to MCP, reaction curve for firm P, and you get an equation like this. Same thing, reaction curve for firm D, and you get this. So you solve these two reaction curves, you solve this reaction curve, you solve this reaction curve, and you get QP and QD. You get QP and QD.
So the MRs are based off of a derivative that includes the quantities of both firms.
Say it again?
The MR, the marginal revenue, is
Yeah.
the derivative of the total revenue and the
Of
quantity dependent on both firms.
No. MR is for each individual firm, right? So MRP is the marginal revenue of firm P. And in order to get the MRP, I have to take the total revenue of firm P and differentiate that with respect to the quantity for firm P. So in the total revenue for firm P, obviously you have the quantities from both the firms, but we are talking, when we are calculating marginal revenue, the marginal revenue is for each of the individual firms.
Got it. Okay, I get it now.
Yeah.
So that P is just the price that is dependent on both quantities because
That's
we
right.
don't know the price yet.
We don't know the price yet, correct. The capital P, we don't know that yet, correct.
Okay.
Correct. So, but you get the two reaction curve, which is the equation uh, in Q1 and what is going on today? So you get the reaction curve between in Q1 and Q2, in this case QP and QD. You have this first equation here, you have the second equation here. You solve them together to get QP and QD, which is what you get here. Okay. Once you have QD and QP, now you can get price because price equals 140 minus 2 times QP plus QD. So if you solve for price here, knowing QP and QD, that's how you get the price. Does that make sense? The key I wanted to emphasize was how are you getting the reaction curves? The reaction curve is MR1 equal to MC1 for firm 1 and MR2 equal to MC2 for firm 2. That's essentially what I did here. Here, instead of 1 and 2, we have this firm P and D. But really what we did was, we'll notice here MRP equal to MCP, which is the reaction curve for firm P, and MRD equal to MCD, which is the reaction curve for firm D, and solve these two reaction curves together to get QP and QD. And from there, you eventually get the price.
Yes, because this is the Carnot model. Sorry if I'm
Yeah,
mispronouncing that, right?
that's the Cournot model, yeah.
Right, and you're essentially solving both. Well, you're solving simultaneously, right? So that's why you have to calculate each MR equated to each MC for each firm in order to get the quantities of each, plug that back into the price formula, and then you get your price from that. And
Yeah.
yeah, okay, perfect.
Yeah. Everybody see this? Should we go to the next one? What do you think, team? So far, so good?
Yep.
Okay, so
Yes.
let's keep
This is
going.
definitely helping out a lot.
Okay, let's keep going. So then what we have here is that, sorry, for the upcoming tourist season, the National Park Service is in negotiations with Dance Dungeon Delvers. So NPS, the Park Service, is in negotiation with one of the firms, which is the firm D, about selling rights to become a preferred provider of tourist services to Alcatraz. A preferred company has the advantage of being featured prominently in advertising and at the ferry terminal, giving the company the ability to set their schedule and number of ferry tours in advance of their competitor. how much at most would Dan's dungeon delvers be willing to pay for being a preferred provider? So what's the question? The question says that, hey, one of the firms, uh, this Dan's Dungeon Delvers, the D firm, you could become the first mover. You could become the preferred company and you will be featured prominently. So you can set your schedule and number of ferry tours in advance of the competitor. So that means you can make the decision before the other party can make. So in order to get that privilege, how much should you be paying for it? So to think about intuitively, part A, we solved the Cournot case where both the firms were competing at the same time. Now you're giving one of the firms, firm D, the preference to be the first mover. How much should it pay for that preference or that privilege? Well, logically, you should pay the difference in the profit where you're competing under Cournot versus you're competing under Stackelberg, and assuming that obviously you'll make more in Stackelberg, so that delta in profit is what you should be willing to pay. So that logic of economic, incentive is still the same, but now we got to figure out what the price and quantity under Stackelberg would be. Make sense what the question is asking? Okay, so the Stackelberg situation. In Stackelberg, what's the algorithm? Our algorithm is we'll start with the firm that is going second. So if DDD is going first, we will start with the firm, the PPP firm, the Paul's Prison Peepers, and start with its reaction curve. The reaction curve of the second firm in Stackelberg is the same reaction curve as what you got in Cournot, which means that you set MRP equal to MCP and you write down MRP, solve it, you get the same reaction curve that you got back in Cournot. So look at this thing. 15 minus 1/4 QD is QP. This is exactly what we got here. 15 minus 1/4 QD equals QP. So this is the same exact reaction curve. So not a surprise. So we got this one. But the trick comes in how I compute the reaction curve of the first mover. So in this case, the first mover is obviously the D firm, the triple D firm. So the reaction curve for D is MRD equal to MCD. To get MRD, I get first the total revenue of firm D, which is price times QD. No surprises there. I expand price in terms of QP and QD. But now I don't treat QP as constant. I replace QP based on the reaction curve of P. So I replace QP by 15 minus 1/4 QD. I replace QP by 15 minus 1/4 QD. So now it's, you can simplify it. It's TRD is a function of just QD now. From here you can get MRD. From MRD set that equal to MCD. That's the reaction curve for firm 2. Or sorry, reaction curve of firm 1. Solve for it, you get QD as 15. Okay, and then go back to the reaction curve for firm P, you get 11.25. A quick check is, well, if firm D went as a first mover, the quantity produced by firm D should be higher than the second firm, which is what we get, 15 and 11.25. Now this is clearly different than what we had before, 13.33 and 11.67. So you do see there's a first mover advantage. From here, you can compute the price. That's 87.5. So how much should you be willing to pay? Will you compute the profit for the D firm in Stackelberg and subtract that from the profit of the D firm under Cournot, and that's what you'll be willing to pay. And that's what they do here. At this price, the profit is 450. Previously, they made a profit of 444.44. So they should be willing to pay up to $5.56. Now, look, I did the math somewhat pretty quickly here. So one can argue that, hey, I didn't fully follow all the math here, which is perfectly fine. But if you read through the slides, you will understand like the math that we did followed the same exact logic as what we have been doing for Cournot, getting Cournot and Stackelberg, getting the reaction curves and then solving the reaction curves together.
Is your is the P into Q, because we're kind of, it's following, the Q is trending one way, the P is trending the other way. Are
That's
they
right. Yeah.
always higher in Stadelberg for the leading firm than in Cornell, or could that
Yeah.
be a
No,
catch?
it will always be higher for the leading firm in Stackelberg relative to Cournot.
Okay.
And obviously, P will trend the other way. Yeah.
And
Okay.
plus, just as you mentioned in the first, when we are calculating first the second movers, if we already did a kernel before, we can just like copy paste pretty much the demand curve. I mean the reaction curve of
The
the
reaction curve for the second firm, yes. Say the follower firm, you can just copy paste, correct?
yeah. So we can just like save some time and exam like refer back to part A,
Yes,
whatever it was. Okay, thanks.
yes, yes. And the other thing I will also, I didn't teach you this trick because sometimes people um, misuse the trick. But if the marginal cost is constant for both the firms, like it's A and B, then you'll notice that like take this one. Um, it's called the reflection theorem. So you can look it up, reflection theorem. My pen is not working, otherwise I've written it down. So what is the reflection theorem? A reflection theorem says that in Cournot, so look at if the marginal cost is constant, it doesn't have to be exactly the same. If it's constant, then uh, the reaction curve for firm 1 is a reflection of the reaction curve for firm 2. Notice that it's 10 minus half Q2, it's 10 minus half Q1. So they are almost, they're not almost, they're exactly the same. It's a reflection of each other. So this happens when the marginal cost is constant, can be A and B. So you can, mirror that way. So,
And in that case,
so
it's A or B, the constant on the Q1
yeah,
equal
will change,
10.
yeah. But the coefficient will be the same, and this will change, yeah.
Okay,
So
thanks.
I mean, I would not use that, but I mean, the way I usually use that is saying that, hey, look, this structure, half Q2 and half Q1, they should be similar. You should not get like half Q2 here and then 5/6 Q1 here. Then you got to think through, hey, why am I getting a different thing? And now that can happen if MC1 had a Q1 dependency or a Q2 dependency, then it can happen. But if it was for the constant, then it should look similar. That's another sort of qualitative check that you're in the right direction or not. Uh, okay. So
Russ, I have a quick question here.
yeah,
So in this particular example, I understood the marginal revenue for firm D, but for marginal cost, the slide says no change. Can you explain that?
the slide says no change. Where did
I
you
mean,
see
not,
that?
yeah, this problem, yeah, right there at the end.
Oh, marginal. So the marginal cost is the same as what we have before. It should be the same. That's why it's no change. Let's see. Marginal cost for firm 2, for firm D is
Oh, okay.
50 plus QD.
Got it. Okay.
Yeah, so the reason I said no changes, in the way I computed the marginal revenue, there was a change versus Cournot, right? But the marginal cost is immaterial. I mean, this point has no meaning. Let's say that, well, marginal cost just depends on the total cost. It will be the same whether you do Cournot model or Bertrand model or Stackelberg model. It's the same. It's all in the marginal revenue.
Got it. Thank you.
Yeah. Okay. So this was my year, but then let's do one more. This is 2024. You can trust or you can't trust bust. Pimcast and Gradient are the two dominant cable companies in the US, where each recognizes its market power despite providing identical products. As an officer at the FTC, it is your job to keep tabs on these firms to ensure that they are not engaging in anti-competitive practices. From your analysis, you know that the uh, market demand for cable, so that the market demand is given to you. The two firms, their cost functions are given to you. In the industry, Pimcast is known to be on the cutting edge of cable technology, where Gradient tends to be a copycat. So for this reason, PIMCAST is able to make strategic choices prior to gradient. In your FTC report on PIMCAST and gradient, you write that once a new technology is adopted, PIMCAST will provide X households and gradient will provide Y households, and the market price is P. So what is it saying really? It's saying that, well, there are two cable providers, PIMCAST and gradient. One of them is a leader here, which is PIMCAST. So they make the decisions prior to gradient. So what kind of model is this? If one firm,
Stackelberg.
Stackelberg model. So if one firm goes before the other one, it's a Stackelberg model. Who's the first mover here? It's PIMCAST. Who's the second guy? Gradient. So, okay, so we got to solve the Stackelberg problem with P and G as the two firms. P goes first. So what's our algorithm? Our algorithm is we start with the second firm, start with G, and write down its reaction curve. What is the reaction curve of firm G? It's MRG equals MCG, right? So you're going to compute MRG based on total revenue for G firm, take the first derivative, treat QP constant, get MRG, equate that to MCG. That's the reaction curve for gradient. Then go to PIMCAST and compute its reaction curve, taking advantage of the gradient's reaction curve, and then go through the process. So I, you know, I don't have the solution here. I was planning to write it down with my real time with you guys, but now that the pen is not working, I will let you guys do this one yourself. You will have the solution. Obviously, I posted the questions in Slack, so you just look at 2024's exam. But frankly, you should not look at the solution. You have all the tools to solve it yourself and then check it whether you did it right or wrong. But really, it's a Stackelberg problem where PIMCAST is going first. Okay, so let's do any questions with this one? I'm going to skip this one solution, but I'm going to go to the
Well,
next problem.
I do have a question pertaining
Yeah.
to, exam, I guess, strategy. So when it comes to studying for the exams and taking the past solutions, how do you recommend solving the problems initially, right? The first attempt is not going to be perfect, right? Do you
Yes.
recommend?
Right. So, how do you say your name? Is it Bio?
Yes, sir, bio.
Bio. Yeah. So I say first thing is print this page, okay, and say, okay, here is all the algorithm I need, all the formulas I need. All right. So first, when you read this exam problem, figure out, okay, which model is he asking about? So here, as we read the problem, we realized, well, he's talking about Stackelberg, right? So we convinced ourselves Stackelberg model. So now you look at this thing. Okay, if it's Stackelberg, what do? I start with the second firm, which is the follower from, and I have to find its reaction curve. So MR2 equal to MC2 is the reaction curve of the follower firm, in this case, gradient. So you get that. Then you said second step is, okay, well, now I got to figure out the reaction curve of the leader firm, the first firm. So in order to get that, I got to get TR1. And reason I put TR1 in a separate line is because I told you that to get TR1, you have to substitute Q2, the follower firm's quantity, in terms of its reaction curve. That was the whole trick of Stackelberg. You do that, then you get TR1 from TR1, which will be a function of Q1 only. You get MR1, set MR1 and MC1 to get Q1. So basically, if you follow this page and the algorithm here, you know how to solve it. Now, step two is actually doing it and making sure that you don't make a mistake when you're taking the derivatives and so on. Most people make a mistake in taking the derivative because they're so, they're trying to go fast and then they miss the two variables and so on, Q1, Q2. They don't treat them how they need to be treated. So that's usually the mistake people make. But having this cheat sheet printed, just one page, and then trying the problems, I think will put you in a good place. So based on the same idea, now we'll do one more problem, and this time it will be a cartel problem. So this is the 2017 exam drug cartel. So I will have the same formula in front of me and say, okay, this is a cartel problem. What's my solution? The solution is a multi-plant monopolist. Let's see if I can solve it or not. So let's take a look. Does that help, Bio?
Yes, that does help. What I tried to do for the first exam was time myself and use the cheat sheet. But I think on the exam, the actual exam in the moment, there's always it's like B and C are just completely different from prior exams. So I think thinking through that is what I'm trying to master before the final.
Yeah, so I would say, look, we still have 4 weeks. At this stage of the game, accuracy is more important than speed. So I would say you guys you have the time as you're learning tonight's concepts. I would go and pick up the previous exams and solve the corresponding problems. Take your time, doesn't have to be fast, but accuracy is more important. Once you have done few of these problems, Korno, Stackelberg, you will naturally, build that mental muscle, that what these steps are. And then once you've done a few times, then focus on the speed. That's the way I would think about it. Because the final material, guys, is harder than the midterm material, which uh, I'm sure you realize that. So first comes accuracy, then comes speed.
Copy that. Thank you, sir.
Yeah. And I'm here all along. So again, if you guys get stuck, don't waste 4 hours trying to figure it out yourself and just ping me, WhatsApp me, or whatever. I mean, usually that will be more efficient because you'll get to the meat of it or whatever needs to be done pretty quickly. Okay, so let's look at this drug cartel problem. Teva and Actavis are two pharma companies selling doxycycline. The two companies are suspected of price collusion and face a lawsuit. Okay, so that's good. Uh, so Angela is asking, are final exams going to cover midterm materials too? The answer is yes, but it's only like 1/3 from midterm. And frankly, the things that you need from midterm is essentially monopoly, pricing, and third degree price discrimination, nothing more. So I would not waste my time on midterm material doing MPL, MPK, all that stuff. None of that comes usually in the finals, even though technically they can ask you. But what does come is monopoly pricing, um, third degree price discrimination, and then maybe this long-term equilibrium condition. So it's very, very selective. But I would spend most of my effort on the post midterm material. So on that note, let's keep going here. So we have a demand which is given as 120 minus 2q. Moreover, the cost functions of the two companies, Teva and Actavis, are given. If Teva and Actavis are colluding, the market price for doxycycline is what? So for collusion, what's our formula? Our formula was MRT equals MC1 equals MC2. Remember that? Which is the same as a multi-plant monopolist. A monopolist having multiple plants, the formula was MRT equals MC1 equals MC2. So that's what we'll do. This was colluding is the same as a monopolist in multiple plants. This was pre-midterm material. And I had told that, well, when you have this as equation, always equate the marginal cost to start with. That gives you a relationship between Q1, Q2. And then you can go back to one of these equations to get, but always start with this one. So I can do the same thing here. I mean, this solution that the professor wrote is also fine, but I will do it the way I usually like to do it, which is setting the two marginal cost to be the same, MC1 equal to MC2. So I can get the marginal cost A and marginal cost of Actavis and Teva. They are right here. 10 QA equals 10. So that means QA equals 1. So I got the first one that, okay, the quantity from the first firm is 1. So I got that. Now I can go back to one of this equation, MR equal to MC. So MR equal to MC. The trick is, how do I get MR? Well, in order to get MR, I have to go back to the revenue equation. So total revenue is price times quantity. It's 120 minus 2Q times Q. I'm not opening Q here. So that's 120Q minus 2Q squared. If you take the first derivative, that is 120 minus 4Q. So that is MR. 120 minus 4Q, which you can open it up as 4QT plus 4QA. So this is MR equals MCA. You already got QA as 1, so you can get QT. QT is 26.5. So under collusion, activists will make 1 unit, Teva will make 26.5, from the demand equation 65. Let me pause here. Does this make sense, guys? For cartel. Yes, no, maybe.
Yes, this one seems pretty easy.
Yeah, so this is pretty easy. Correct. So that's cartel. Then comes the next one, which says that, okay, Teva and activists claim that they do not collude. Okay. Instead, they simultaneously decide the quantity of doxycycline supply. When I decide simultaneously on quantity, what game am I playing? What game am I playing? If I decide simultaneously on quantity, that's the way I'm competing. What game am I playing?
Perfect competition?
Corno.
Or no?
No, Kurno. I mean, there's no perfect competition. Perfect competition is we have many firms. Here we only have 2 firms. So by definition, it is an oligopoly model.
Right.
But the fact that I'm competing on quantity and making decisions simultaneously, that means I'm in a Kurno world now. So then if Teva and activists are not colluding, then Teva would have a market share of what? So when I say market share, that means how much quantity does Teva produce? QT divided by total quantity in the market, which is QT plus QA. So you got to find that. So now it's a Kurno. What's the algorithm for Kurno? Algorithm for Kurno was find the reaction curve for firm 1, find the reaction curve for firm 2, solve the 2 reaction curves simultaneously. That gives me the 2 quantities. So this is what let's do. Let's step through this one by one. Well, the reaction curve of Teva is MRT equals MCT. So that's right here. This is the reaction curve for Teva. The reaction curve for activists is MRA equals MCA. And we got to solve these 2 reaction curves together. Well, the trick is to get MRT and MRA. You know how to get MRT and MRA. Compute first total revenue for Teva, which is price times QT. Open it up, compute the total revenue for activists, price times QA, open it up, take the first derivative of TRT and TRA with respect to QT and QA. So MRT is this, MRA is this, set them equal to MC to get the reaction curve of firm 1, reaction curve for firm 2, solve for QA and QT. You get the numbers, and then the market share is really QA. For in this case, they wanted the market share for Teva as QT divided by QT plus QA. So QT divided by QT plus QA. So 83.33%. So if they were to compete in a Kurno world, Teva will have almost 83% of the market share. But I hope you are seeing that the problem is actually quite simple. If you know the mechanics of how to play these different games, whether it's Cartel or Kurno or Stackelberg, yes, the algebra is a little tedious, but the steps are not complicated. Hopefully that intuition is coming along. Okay, let's try one more. Amerisource Bergen. Corporation. ABC Corporation, the sole distributor for both Teva and Actavis. Teva has reached an agreement with ABC that its supply will be sold first. So now we have a first. Somebody is going to go first. In this case, Teva is going to go first, giving Teva a first mover advantage over Actavis. Teva chooses the quantity of doxycycline produced first, which Actavis then observes before making a production decision. So what does this look like now? Teva is going first.
Stackelberg.
Stackelberg. So what's the Stackelberg algorithm? Stackelberg algorithm is start with the firm that is following, in this case, Actavis. The response function for Actavis will be the same as what for Kurnoval. I think Janos was asking this question. So for Actavis's response function, I write down this directly from the previous page. Where is my previous page? Previous page here. If you look at the Actavis function, it's QA is 60 by 7 minus 1 by 7 QT. QA is 60 by 7 minus 1 by 7 QT. So I can write this thing directly from the previous example. I save like 2 minutes. And then I write down I try to figure out the reaction curve for the leading firm, in this case, Teva. And the trick was how you compute TRT, and then from there MR and so on. So you can do that. And when you do that, you get the quantities as different numbers. You get Actavis as 4.70. Since Teva is first mover, it should produce more than what it was doing under Kurno. So now it's making 27.08. Previously it was making 25. So it makes sense that by going first, its quantity went up. What about the price? Well, the price is 56.44 as a first mover. And what are they asking? The new market price. They're asking for the new market price. So you can get the new market price as 56.44. So if you think about this problem in the 2017 Teva and Actavis, really what it did was it's a long problem, but it's a very simple structure. Part A was what happens if you collude. Part B was what happened if you played the Kurnos game. And part C was, well, what happens if you did a Stackelberg first mover advantage. Okay. Good so far?
Yes.
Yep.
Okay, let's try one more. 2017 finals. So see, the previous one was 2017 finals. This is also 2017 finals. So the same exam, two problems. For many years, the demand for granulated chlorine for swimming pools has been satisfied by two suppliers. So you know that's a duopoly. Blue Vista Pool Supplies and Clearpool. Both companies are similar size, fully understand the market demand and the production cost of their competitor, recognizing their pricing power and generate a decent profit. Their respective long-run cost functions are given. So the two firms are given, their cost functions are given. Okay. What else? Pool owners purchase chlorine according to the following demand function. So you have that. Okay. Okay, what is it? How are they making decisions? Pool chlorine sells for dash kilogram. Blue Vista sells this many. So the price is required. Pool chlorine sells for $1 per kilogram. Okay. Blue Vista supplies this many million kilograms, and Clearpool supplies this many million kilograms. Okay, so in this case, it's a duopoly. Where does it, like, if you have to figure out like what model are they talking about? Let's see if there's any keyword. For many years, the demand is given by this suppliers. That's duopoly, this and this. Both companies are similar size, fully understand the market demand and the production cost of their competitor, recognize their pricing power, and generate a decent profit. Their respective long-run cost functions, blah, blah, blah. Okay, so it doesn't say anything. If it doesn't say anything, then clearly it can't be Stackelberg. So the safe option is, well, they must be competing as Cournot. It can't be Bertrand because Bertrand will be like killing each other, so the profit will be much lower. So if you want to maintain some decent profit, the better way to compete is through Cournot. So even though it doesn't say it, that becomes a default choice. So I will solve this as a Cournot. So here is the solution. It says that this is a Cournot market structure, and the companies will compete by controlling the quantities to maximize the profits. So once you know this Cournot market structure, then you got your standard process, get the reaction curve for firm 1, get the reaction curve for firm 2, and then solve them together. Make sense? And I think, I think you know the process. How do you get MR, and your MC is pretty straightforward, and you solve for it. So I'm going to skip the algebra behind it, but you know the mechanics of it, and you should try it yourself and convince yourself that these are the numbers you're getting. That way you will have a practice on the algebra as well. Okay. Part A makes sense. Can I go to part 2 or part B?
Yep.
Part B. Clearpool hires a chief marketing officer who never went to business school. He believes that the idea of market power is an MBA cliche. Instead, he thinks that the maximum profits are achieved with a dominant market share through intense price competition. That word, intense price competition, means now you are heading towards a Bertrand model. Thus, he institutes a series of price cuts to increase Clearpool's market share. Blue Vista Pool has no choice but to respond. Eventually, the price for chlorine will settle at this much dollar per kilogram. Blue Vista will earn a profit of X. Clearpool will earn a profit of Y. So if we have a Bertrand, what's the algorithm? It's again the reaction curve of 1 and reaction curve of 2. Reaction curve of 1 is price equal to MC1. Reaction curve of 2 is price equal to MC2. So that's the reaction curve from 1, which is blue Vista. So that's that. And Clearpool, that's that. Solve the two things together, you get the quantities, and from the quantity you get the price. You also compute the profits here. Profits are actually decent, but I don't know what the profit was. Here it should be even higher if you did Cournot. Clearly, you can notice that in Bertrand, the price is lower. The price is 30.14 versus Cournot, where you could have charged 33.83. So that directionally makes sense. But Bertrand would be the case for the lowest profit. Okay, so again, we are looking at keywords like intense price competition. Part C. Blue Vista becomes the target of Carl Hemsley, a notorious corporate takeover shark. He negotiates the sale of the company to Clearpool. So very interesting. So Blue Vista is now sold to Clearpool, and shareholders and regulators approve. Using both factories, Clearpool now earns a profit of this, pricing is this, and selling this many kilograms. So what really happened here? What really happened here is the Clearpool company is sold to Blue Vista. Or sorry, the other way around. Blue Vista is sold to Clearpool. So from our vantage point, this kind of acquisition is the same as collusion. The two companies are now colluding because they're part of the same structure to supply the products. So we'll use the collusion cartel model, which is really MRT equals MC1 equal to MC2. MRT equals MC1 equal to MC2. So the way we start the problem is we start with the MC1 equal to MC2. We do that. That gives us a relationship between Q1 and Q2. Then go back to MR and solve for it. So if we did this, the price is 36.1, the total quantity is 13.9, and the profit is 323. It's higher than Bertrand, you expect that. It may be even higher than Cournot, frankly. And that we don't know exactly which one will be higher, but certainly will be more than Bertrand. So what are we learning from this example? Again, the learning from this example is there are some keywords that you should be able to recognize that tells you what kind of model this is going to be. Cournot, Stackelberg, Bertrand, or collusion. And then once you know that, the rest is just following the process. Make sense?
Yep.
Pras,
Yeah.
to be here. I had a question about the Bertrand and Stackelberg.
Yeah.
So in the prior example, someone makes a move first, and the other company is forced to respond. But the wording of the example makes it clear it's a Bertrand. I don't think it's this one, it's the other one, the prior one, maybe A. No,
This
something
one?
where it says one company cuts the price and then the other company is forced to respond.
Yeah, so
This
here,
one, yeah, exactly.
yeah.
Okay, so they have to respond, which is, leader, but I guess the wording just makes it click, makes it seem like it's obviously
Yeah, no,
written.
I know what you're saying. You're saying that, hey, look, I thought Bertrand was simultaneous decision making, but competing on price. But here it seems like it's sequential decision making. The first guy makes a price cut,
Yeah,
and then the other guy responds. I mean, to be honest, in the Bertrand case, even sequential would be the same thing because now you can react in the sense that, well, okay, if you're going to do price P1 and if I undercut you by P2, I can take the whole market share. But you're right. I mean, but in general, the Bertrand is simultaneous decision making than sequential. But yeah, here the wording could have been a little bit better. Uh, Actually, this is a good question to ask. You can ask ChatGPT directly. I can maybe learn something also. What happens if firms make sequential decision making but compete on price? Is that still a Bertrand model in oligopoly? Bertrand simultaneously, a sequential Bertrand, I mean, frankly, yeah, we haven't, I mean, for what we have learned or what we will learn in this class is usually this one, simultaneous decision making, uh, not so much sequential Bertrand. So yeah, the what you're observing is correct, but really, this is all we know how to solve in this class.
okay. Thank you.
It's a good point. By the way, speaking of this, the Chat GPT is obviously a great place to further strengthen your concept understanding. Hopefully, you guys are using these AI tools. It makes life much more easier these days. Uh, so, all right, so we did this one. What else? So we have done now Cournot, Stackelberg, Bertrand. We have done collusion cartel. What we haven't done is dominant follower. That's the last topic. But before we go there, these are, in lecture notes 10 and 11 in the additional problem sets, you have this very simple problem which says that, hey, if this is the total demand, there are two firms with this kind of cost structure. what is the price and quantity under different market conditions, when it's competitive, when it's collusion, when it's Cournot, when it's Stackelberg. It's a very, very simple problem. Now that you have gone through all of this, you can do this pretty quickly. So I won't, so the solution is included, uh, but maybe, after tonight's session, just try this problem. It's the easiest one, but it will help you remember the mechanics behind different market structures. What do you do when it's competitive? What do you do when it's collusion? How do you solve Cournot and how do you solve Stackelberg? Okay, so that's here. So now let's talk about the last model, which we haven't talked about, which is the dominant follower firm. So what's the structure here? In the dominant follower firm, it is still an oligopoly, but the firms are broken down into two kinds. One is a leader, the dominant firm, and the others are just followers. Did he talk about this in class? I think some years he includes this, some here he doesn't. I hope he did that this year, that it's included. You guys remember this?
I don't know if
No,
we've covered all of oligopoly yet. I think we have quite a few sessions this upcoming weekend on the Philly side where we'll get to this.
Oh, I would have thought, given that you have so few weeks left, you should have done these things. On the West Coast, did you guys cover oligopoly yet or not?
I think we covered the Corno, Bertrand, and Stackelberg. I can't really recall this dominant follower, and we had the exam this weekend, and we didn't have Econ Plus. So
Yeah,
maybe next week.
he's mentioned a few times that he has less time with us than usual, so I don't think he's covered all of this yet.
Okay, but I'll teach you tonight. It's not that big a deal, but hopefully he will cover this, because clearly there are exam problems based on this idea. So what is a dominant follower firm? The dominant follower firm is like there's one firm which is the dominant firm, which is the price setter. Okay, and then there are multiple follower firms which are price takers. So in the same model, you have the dominant firm dictating the pricing like a monopolist, and you have the follower firms that is receiving the price and behaving like a perfect competition. So in the same model, you have two structures. So what's the approach? The approach is the follower firms are price takers and therefore follow the perfect competition pricing policy. So for the follower firms, price equals MC. Okay, price equals MC. So you calculate MC for each follower firm. This is the governing equation from them. And from this thing, you can calculate the total supply supplied by follower firms. Remember in the midterm, you had done a problem where if you had multiple firms, or they had 10 identical firms, you could compute the supply provided by those 10 identical firms. And the way you had done that was you set each individual firm's profit maximizing quantity P equals MC. And from that, you written down Q, small q in terms of price. And then if you said, well, if we have 10 identical firms, then 10Q equals whatever the thing is. That's the total supply from the follower firms. Exactly the same thing here. For the follower firms, we write P equal to MC for each follower firm. And from there, we aggregate the supply from each firm to get capital SF. Capital SF is the total supply provided by the follower firms. Okay, so that's how the follower firms are doing. Now, if the follower firms supply S of F, how much does the leader firm supply? Well, the leader firm will supply the total demand minus S of F. The leader firm will supply ST, supply from the dominant firm will be the total demand minus the supply from the follower firm. So once you have so this is the demand, ST is the demand that the leader firm will face. Once you have that demand, now you can set the price and quantity of the leader firm by using the monopoly pricing, which is from that demand, get the corresponding MR, set MR equal to MC, and then that's how you get the price and quantity. Okay, so what have we done? We have said that in supply, in a dominant follower firm, first I need to compute the total supply from the follower firms using perfect competition ideas. Then from the total demand, I got to subtract the supply of the follower firm. That gives me the demand that the dominant firm is facing, and then the dominant firm sets the price. So I can use the monopoly pricing structure, but using the demand that the dominant firm faces to set price and quantity. That's really the process. Let's take an example. This is 2014, but the same example came in 2018, something similar, and then later on as well. So let's do the 20. Well, actually, we can do either one. Let's do this one. That's fine. 2014 De Beers. The world market for diamonds is dominated by one low-cost supplier, the De Beers Corporation. The cost to De Beers of extracting and shipping diamonds to the world market is given by this. So that's the cost function of the leader firm. De Beers is not the only supplier in the market, however. There are many small but less efficient mines throughout the world, including mines in Russia, Canada, US, South America, and Australia. These many fringe firms are all privately held firms that simply supply diamonds as long as the additional revenues earned at the world price cover the marginal cost of production. So there is a De Beers a dominant firm, and there's a lot of these fringe firms that are followers. If we were to rank these fringe firms from the highest to lowest or lowest to highest for each cost for each quantity of diamonds sold, we would obtain the supply function of the diamonds from these fringe firms. The fringe firm's total cost is given by this. Okay. De Beers has estimated the world price of diamonds to be given by this. How many tons of diamond does De Beers produce and at what price? What are De Beers' profits? How many tons of diamonds do the small private firms collectively supply to the market? What are these firms' collective profits? What marginal cost would all surviving fringe firms pay per ton in this market? So the situation is you have diamonds market, you have De Beers as a dominant firm, his cost function is given. You have a lot of fringe firms, their cost function is given. So the question is, what's the price that De Beers sets? How much does it produce? And how much do the fringe firms produce? Okay. So back to our algorithm. Here are the steps. Well, I will start with the fringe firm supply first. Like, okay, how is the fringe firms working? They are working by setting price equal to MC, just like how anybody in perfect competition would do. And from there, I got to add up the supply from all the fringe firms. So let's do that. The MC for the fringe firms based on the total cost equation here is 2 plus QF. So fringe firms will set price equals 2 plus QF. That means QF will be price minus 2. So price equals 2 plus QF, price equals MC, so price equals 2 plus QF, which means that QF is price minus 2. So QF is price minus 2. Okay. They haven't told me how many fringe firms are there. If there were 10 fringe firms, then I would do 10Q is minus 2 plus P. But in this case, they don't tell me this is the all fringe firm they have, so it's minus 2 plus P. I don't have to multiply anything, but in principle, if they had told me there was 10 fringe firms, I would have multiplied by 10. Now I got to compute the demand that the dominant firm will face. What is that demand? That demand, QD, is the total demand minus what is supplied by the fringe firm. So Q minus QF. Q is 50 minus P, the total demand, minus QF is minus 2 plus P. So solve for QD, so QD gives you 52 minus 2P. 52 minus 2P. That's the residual demand faced by the dominant firm. If that's a demand frame, the dominant firm, which behaves like a monopolist, how does a monopolist set its price? It sets its price by setting MR equals MC, and you get MR from the demand equation. Here, the demand equation is the demand that the dominant firm is facing. So 52 minus 2P. You recall that our trick to finding MR in monopoly was write down price in terms of quantity. So write down this term, Q equals 52 minus 2P in terms of price equals quantity. When you write this thing down, it becomes price equals 26 minus half QD. If that's my demand equation, what is my MR? Same intercept, twice the slope. So 26 minus QD, that will be my MR. MR is right here, 26 minus QD. MR is 26 minus QD. You got to equate that to the marginal cost of the dominant firm. In this case, De Beers, the marginal cost of De Beers. MCD, and MCD is 2. Marginal cost of De Beers is 2, and that comes from here. If you look at the total cost of De Beers, the marginal cost is 2. MR equal to MC, 26 minus QD equals 2. Solve for QD is 24. Go back to the demand equation to get the price of 14. So what this is saying is De Beers should set the price as 14. The quantity it will supply is 24. That's those two things. The fringe firms will supply the remaining, and that's P minus 2. That's 12. So the total supply in the market will be 12 plus 24. That is 36. The price will be 14. And basically that's really what, and then you can calculate the revenue and profit and so on and so forth. Let me pause here. Does it make sense? The dominant follower firm, you computed the follower firm using perfect competition, you computed the dominant firm using monopoly, and then you brought them together. Okay, let's take one more example. Maybe this will become clear. This is 2018 finals. Share and share alike. Laporte Chemical Company produces polymer chemicals, which are the raw materials used in the production of many different kinds of plastic. Founded in 1777 in Delaware by Laporte brothers, the company is the recognized dominant leader of these materials to the world markets. With state-of-the-art continuous process equipment, Laporte produces at a total cost of this, where QL is the quantity produced. In New Jersey, 10 smaller price-taking suppliers of these polymers compete with Laporte, each with the cost function this, where Q is the quantity produced by each of these firms. The total market demand for polymers is this. So the total market demand is given. The cost function for these fringe firms is given, and there's 10 such firms. And then the cost function of Laporte, the leader, is given. So how much, what is the market share of the leader? That means how much do you produce as a leader as a ratio of the total production. So what is QD or QL, I would say, from Laporte divided by QT? That's what you need to compute. Okay, so what's the process? The process is, well, let's start with the follower firms and get the total supply from the follower firms. The follower firms will act by setting price equals MC. So MC from here is 7 plus Q, and they will set that equal to price. So price equals 7 plus Q. So from here, you get Q as a function of price. Q equals P minus 7. That is the supply equation for one follower firm. Since there are 10 follower firms, the total supply for follower firms is 10 QF, 10 times QF, and that's 10P minus 7T. That is the total supply from the 10 follower firms. That's step 1. Step 2, well, if this is the supply from the follower firms, compute how much supply or what will be the demand that will be faced by the dominant firm. Well, the demand that will be faced by dominant firm is the total demand minus whatever is supplied for the follower firms. The total demand minus whatever supplied by follower firms. So 300 minus P minus 10P minus 70. So that's the demand faced by the leader firm, dominant firm. But once you have the demand faced by the dominant firm, now you will know the pricing. The dominant firm will price like a monopolist. So from the demand, you can get MR and set the MR to MC. Okay, so how do I get MR? Well, we know the trick. If you write price in terms of quantity, then same intercept twice the slope. If you write price in terms of quantity, price will be 370 by 11 minus q by 11. The MR must be the same intercept 370 by 11 minus 2 q by 11. So that's my MR. Set that equal to MC. MC is this from the dominant firm. Set the two things together, solve it. You get the Laporte, the leader's quantity as 136.63. From there, you can get the quantity of the follower firm, and the market share is QL divided by QL plus the follower firm. S49, so this must be 142.2, not 14.2. Okay, 14.2 is for the individual one. Since there are 10 such things, so there are 142.2. So the market share is, this is from the leader, this is from all the follower firms, so 49%. Okay, so I will pause here. But if I go back and try to recollect what we did tonight, really we were looking at different oligopoly models. And in oligopoly, I said the key idea is interdependence, and interdependence is measured by reaction curve. So we studied how we compute reaction curve for different variants, Cournot, Stackelberg, Bertrand, and most recently dominant/follower firm. This is on the non-cooperative side. And then on the cooperative side, obviously collusion and cartel. Let me pause here. Does this make sense, what we did tonight?
Pras, I just have a quick question. I think in the dominant follower examples, so I think the first what we did there was not mentioned exactly how many followers. So I just assume whatever is there, sums up the follower, because in a second it specifically was said 10.
Yes, in the first one, it didn't tell me how many follower firms were there. So you assume that whatever I compute, that is the total supply for follower firms. In this case, maybe it's only one follower firm.
Yeah, cool. Thank you.
Yeah.
Is it on exams usually mentioned, or is it just like very random? So just need to pay attention.
No, they will mention that. They will mention that.
Okay, cool. Thank you.
So I would say, look, I had posted a whole bunch of exams. Let me see if I can find the exams for you guys. I posted a whole bunch of exams in the Slack system. So let's see if I can pull them out. So let me share my screen again. I'll just stop here. So this one, for example, is 2022. This is 2023. So 2022 doesn't matter. Pick any one of them. So if you scroll down here and not that one, but if you got today's concepts, then maybe try this one. So it says in a Star Fox and Gaggle. In a world of online advertising, Gaggle's cost function is given. Star Fox is considering entering the market. In order to do so, they would have to acquire. So this is this thing. The demand is this much. Since Gaggle is first in the market, they should produce this many ads, and therefore Star Fox should produce this many ads. So in this case, Gaggle has a first mover advantage, and Star Fox is following. This is an example of Stackelberg. So you can try this one. Part B says, well, seeing that Starfox is about to make an investment in equipment and capital, Gaggle produces an ad level of this much, trying to discourage Starfox from making an investment entering the market. So this is the reaction curve. It's already telling you how much quantity they're going to produce, see if that helps or not. So this would be a good example to try to test out your ideas on Stackelberg and Cournot. So that's one. So pick 2023. I'm sure there is problems here also. So my point is, if you scan through it, you will pretty quickly find out, which problems make sense. Like this one, White Star. You're a manager of White Star, a real estate development company. Your company has been looking for an opportunity to build a new apartment. while the city is very big, there will be only one other competing building managed by Apex Properties. So you are W, the other company is A, the market demand is given, your cost is given, A's cost is given. Suppose the planned number of units in each buildings are chosen by White Star and Apex Properties, respectively around the same time, without collusion. What would, how much will each make? So same time, competing on quantity, that's a classic Cournot. So this is the classic Cournot part A. Then part B might be Stackelberg. Like one of you guys can go first. I don't know what the part B says. But anyway, so my point is pick the previous exams and you'll find the questions very quickly, and that will give you a sense of how much you have learned. I would say at this stage, now that you have some time, and I would study the material, try to master it as one topic, like tonight's topic. Try out the exam problems. If you do like 5 or 6 such problems, your mental muscle for this kind of problems will automatically be formed. And that's the way I would do it. But let me stop here. Sorry, Janos, do you have a question?
Yeah, just a very quick question.
Yeah.
I haven't went into the details yet, especially on the dominant, but at the first instance, or like as a first look, the Stackelberg and the dominant follower might look very similar, where you have kind of a first mover or dominant.
No. So Stackelberg, they look similar in the sense that there's one dominant and other followers. But Stackelberg, remember, both the firms in Stackelberg are acting like an oligopolist. In dominant follower firm model, the first firm, the dominant firm, is acting like a monopolist. The follower firms are not acting like an oligopolist or monopolist. They're acting like perfect competition. They're price takers. The
And
difference
somehow we can see this in the wording that I guess
in the
that's
wording, it will tell you that these are follower firms and they're fringe firms and they are price takers. They will tell you some words like that.
okay, cool. Thank you.
Yeah. Okay, good. Any other questions before we close tonight? If not, I thank you for staying. Thank you for the time. Let me just, before I stop the recording, look, we'll have to play a little bit fast now because of the limited time. So, which means that I will push more content towards you guys, not trying to stress you out, but I'm getting stressed out that we have so little time, a lot to cover. I want to make sure that you're well prepared. And in return, I do ask that when I'm sending these sessions, please take the time to read through it, browse through it, practice through it. It's for your own benefit, frankly. This material does take some time to sink in. I mean, I do it very fast because I've done this for so many years now. But when you're reading it for the first time, when somebody explains to you, it seems like obvious, yeah, no big deal here. But when you are trying to do it on your own, it's not that obvious. So the more you practice sooner, the better you will be. And then one last comment, in 4 weeks time, when you take micro exam, it's going to be even harder because you have the accounting in the same weekend, I assume, unless Wharton has changed.
No, same weekend.
Same weekend, right?
And
so
we
you'll
have a
have
class as well on strategy.
yeah, so you'll have like more than one exam the same weekend. So your head will be spinning in the base case. All of us have went through that nightmare, but that's why the sooner you jump on this, it will be less stressful towards the end. Okay. I'm here. Text me, call me. So please take advantage of it. Uh, now is the time to do all these things so that it's better towards the end. Okay. With that, I'm going to close. I'll obviously post the next video also sometime, or next material sometime shortly. Okay.
Thank you, Pras.
Yep.
Have
Thanks,
a
Chris.
great night, guys.
Thank you,
Cheers.
Pras.
Thank you.
Thank you, Pras.